Hi everybody. So today I am recording from my house. I'm quarantined, but I can still do these videos and teach you guys virtually from home. So today we're starting chapters 3 and 4. We'll start chapter 3, we'll do vectors. This should be mostly a review for you guys, but we're going to do a little bit more complex things with the vectors. Then chapter 4, we'll go into 2D kinematics, where we will actually look at problems that are moving in both the x and the y direction at the same time, and then we can use vectors to solve those problems. So let's start off with this question: what is the difference between Cartesian coordinates and polar coordinates? So the main difference between Cartesian and polar coordinates, main difference is that Cartesian polar. Cartesian is what you've used through your math class so far. You have an x and a y for your coordinate points. This also gives you, let's move that out of the way, this gives you two lengths to measure from the origin to your point, right? For polar, this looks different. It gives you an angle theta and a radius r. So starting from the positive x-axis, it will measure an angle, either positive or negative, and then it'll give you a length of the radius. Now this only gives you one length to measure the distance from the origin to your point. And the theta will then tell you which direction to travel in order to reach your point, right? So let's apply this a little bit. So let's see, we have the polar coordinates of a point are 5.5 meters and theta equals 240 degrees. What are the Cartesian coordinates of this point? All right, so we zoom in here. We have an angle and a radius that are on this xy plane, right? And we have the radius r, we have the angle theta. We want to convert that into an x and y coordinate for Cartesian, right? Oops. So there are two ways to do this. Method one, you can use trig, right? So there are a couple trig identities that work with polar coordinates. The first one is that sine of theta will give you y over r, and that cosine of theta will give you x over r. So you can get the y distance by solving that equation there, because we have theta and we have r, and you can get the x distance by solving that equation right there. So y would equal, if you multiply that r over, you'd have r sine theta, and x would equal r cosine. Whoops, didn't register those letters. Cosine of theta. Okay. And we know that theta is 240 degrees, r is 5.5. So you could plug those in and find your answer. Another more common way that a lot of you may have already thought of is to use geometry. Now, to use geometry, you would use a right triangle, right? And then you would, let's see. So I'll actually draw this according to this line. You have line there, line there. Okay, so you have your x, your y, your r, and your theta. So if you look at this, you could also find, you would be able to solve the exact same identities. This basically is going to give you the same method. Now, to find that theta, this is going to be different, because that theta is obviously not 240 degrees. That is 240 degrees minus this section over here, which appears to be 180 degrees. So theta will be Is that 60? 60 degrees. Okay. Now our theta is 60. What we can do now is we can look, if we take sine of theta, okay, that is still opposite over hypotenuse, SOHCAHTOA. So you'd still have y divided by r, so your y would still be r sine theta, but you have a new theta. Now, trigonometry is going to actually take care of the difference in theta. It doesn't actually matter if you use 240 or 60 because sine and cosine will take care of that difference for you. However, if you use this method over here, if you use the trig method, here you will get a negative 4.76 meters, and here you will get a negative 2.75 meters, giving you a coordinate of negative 2.75 and negative 4.76 meters. And that is the correct answer. Now, if you use the geometry method, you will not get the negatives. The theta being 240 degrees, the trig, I don't want to say like the trig knows, but the trig knows that you are in that third quadrant with 240 degrees. So it will give you those negatives. If you do this trig, the y will actually equal 4.76 meters, but you can see on your drawing that is a 4.76 meters down. And then if you do the x, that would give you 2.75 meters to the left. So you would have to realize that down is negative, left is negative, and get those negatives for yourself as you put them into the Cartesian coordinates. But either method is going to give you almost the exact same way to solve the problem. It just depends on how your brain is going to work. If you can memorize trig, that's much easier. If you want to just draw your triangle and SOHCAHTOA your way through it, that's fine too. Just remember that left and negative are down, and draw your triangle so that you can see the direction of everything and where it's at. Okay? All right. Our next problem. For the following three vectors, find A plus 0.5B minus 0.75C using the head-to-tail method. Show the resultant vector R in a different color. So if you guys remember, or if you don't remember head-to-tail method, what you do is you draw your vector like so, starting from its original point. Here, I'll use red for this. Starting from its original point, draw your vector, and I believe it is best practice to not include both sides of the arrow, just because when you start using head-to-tail method, it can get kind of confusing. Now, if we want to add 0.5b, we want to draw half of that length b. And if we want to subtract 0.75c, there are two ways that you can do this. You can either draw your 0.75, I'm just going to say that's an estimate of, this is a half, this 3/4. That was about right. Here, I can fix that. Here we go. So it's about 3/4 of the way down. You can draw it that way, but then to subtract it, you would go head to head. So let me show you that here. Let's move this vector down here. And we're going to add 0.5b. So let's move this guy down here. Match head to tail. Okay. So literally the head of one arrow goes to the tail of the next to add them together. Now, if you want to subtract, there are two ways that you could do this. You could either take this vector and then put it head to head instead of head to tail. That is essentially subtracting. Or what you could do is you draw your C backwards. So we go down 0.75, but we put our head on the other end. And then we can move that guy over right there. Either way, we're going to get the same resultant. So let's put our ruler out here. Start from the beginning, go all the way up there. Let's see if we can get that right. That's going to be pretty close. Oops, pencil. All right. And let's get rid of the ruler. That would be our resultant vector. Okay? So two different methods of subtracting. You can either do head-to-head instead of head-to-tail, or you can draw your vector backwards. Either way, you're able to use head-to-tail method on that one. Okay. All right, that's a quick intro to using the head-to-tail method. A quick, dirty intro to Cartesian coordinates and polar coordinates. The work got kind of messy, got away from me there. But it's important to know what the difference is between Cartesian and polar coordinates and how you can go back and forth between the two. Okay. Next video, we will expand on our usage of vectors and continue going on until we hit 2D kinematics.